Yeah, right. Oops, actually, let's do 22 first. Opposite, adjacent. So we're doing tangent of 29 over x. These trade places. X should be 9 divided by the tangent of 20. And so I'm just going to do that in my calc real quick. Oh, fail. 9 divided by tangent of 20. And 24.7 is what we're looking for here. Simplifying complex fractions, do the top and the bottom separately. I'm going to take and multiply 3 to the first fraction here. This will allow us to have a common denominator. And then I can actually subtract. That's the top. The bottom, 5 top and bottom here. This is going to give you 4 over 5d plus 20 over 5d. And this will be 24 over 5d. That's the denominator. So I'm going to keep the 2 over 3d, change this division symbol to multiplication, and flip this over. Okay, so from right here I can see that the d's are going to cancel out, and you're going to have 10 over 24 times 3 is 72, I believe, yes. Now, both of these numbers are divisible by 2, so I'm just reducing a fraction here. This would reduce to be 5 over 36. Amplitude and period. Amplitude is the height of the wave. We got 3 and -3, so your amplitude is 3. Period, this is a cosine function. One wave, 1, 2, 3, 4, 5. So I make one complete cosine wave between 0 and 4 pi. So my period is 4 pi. Write in logarithmic form. We're just going to swing this down. For the base of your exponent becomes the base of your log. So the 5 is going to swing down to be a subscript. The 4 is equal to the log base 5 of 625. All right, law of sines. And I could figure out the third angle if for some reason I needed it there, but I'm just going to do sine of 64 over the side across from it is proportional sine of 42 over the side across from it. We're going to cross multiply here. So b times the sine of 64 equals 31 times the sine of 42. What you're going to end up doing here, 31 times the sine of 42, and then I'm going to end up, to get b alone, dividing that by the sine of 64. And so b here is about 23.07. It says nearest tenth, so we'll go 0.1. Okay, inverse variation, y equals k over x. So when y is 15, x is 11.2. So I'm just going to solve this real quick to get the k value, which is 100, sorry you guys can't see that, 168. I just multiplied both sides by 11.2. So the actual equation here would be 168 over x. It says find the missing value. So I know the x coordinate, but I don't know the y coordinate. So if x is 7 in this situation, what's y going to be? So I've already got the 168 up there divided by 7. So y is going to be 24 here. Arithmetic, you take an average of the terms, so this would be 16 plus 10 divided by 2 to get the term in the middle. 26 divided by 2 is going to be 13, and you can here see that we're subtracting 3 every time. Geometric is in between the terms. You would multiply these two and take the square root, so 2 times 12.5, and then the square root of 25 is just 5. And if you're trying to determine what you're multiplying, any term divided by the term before it, so in this case, if I would take 5 divided by 2, that's my common ratio. I know they're not asking this. The question's asking for the 5, but just to show you how to do this. So if I do 2 times 5 over 2, and then if I do 5 times 5 over 2, that should give me that 12.5. So I'm just checking my work there. Okay, evaluate the series. So looks like we're adding 4 between the terms. So to evaluate the series means you're going to add up all the values up to this point. So I'm just going to real quick write an explicit formula for this. The first term is 21. I'm adding 4 between the terms, and this is on the formula sheet. Do not add these together. You want to distribute this. And the formula for this would be 4n plus 17. Okay, now the reason, this is not where I'm going with this, but the reason I did that, I have to figure out what term 61 is in this list. So 61 is 4n plus 17. I'm just going to solve this really quick for what term number that is. So 61 minus 17 is 44, divided by 4 is 11. So in this case, the term number is 11. This is the 11th term. Now, also on your formula sheet, let me see if I can lay this out here so you guys can see it real quick. The sum formulas are with the S. Anytime you're evaluating, you're finding the sum. This is the sum of an arithmetic. That's where you're adding the same thing between the terms. So you see, I needed the N because I need the number of terms. So this is 11 terms, 11 over 2. The first term is 21. The last term is 61. We can see that right in the problem. So this is going to be 5.5 times 82, and that should give you the sum. The other way you could do that problem, oops, not on screen, sorry, 451 would be the answer here. The other way you could do that problem would literally be just add all these up, but put in the missing numbers. Maybe that's faster than doing all that work that I did, but the evaluation of a series is just to add up all the terms. Okay. Change of base is changing to base 10, so we can do on the calculator typically. So this would literally be log of 16. It's log base 10, so that way I can type it. So log 16 divide by log 5. Whoa, maybe I should type the log button first. And go ahead and hit equals. And so this is 1.72. It doesn't really tell us what to round to, so I'll just go nearest 100 there. Graph the function, state any asymptotes. Okay, x, we would not want x to be -1, so the opposite of that, because that would cause that denominator to be 0. There's nothing added or subtracted here, so y equals 0 is going to be your other line to help you graph this here. So -1, vertexal line at -1. All right, because of the squared, these two branches go the same direction, and because everything's positive here, we're going to go up. So we're going to look here. Graph should look like that. Domain here, you go left and right forever, so this is actually all real numbers, but x can't be this -1. We're never going to run into that. Now the y values here are different. Everything points up here. You'll always get positive values no matter what you plug in for x, and so everything is above this horizontal line here. So this is all real numbers, but y has to be greater than strictly because you're not going to touch this 0, and it's greater than because it goes above. See if I can do a couple more here. So 33. Basically, what I'm going to do here is I'm going to take the fourth root of 625. So we've done fourth roots a little bit earlier on in the review packet here on the front page. This should be 5, so I know that. So this is a perfect fourth root. Now, what you do with the exponents is divide them by the root. So for the x, it'd be 20 divided by 4. And for, y, it'd be 32 divided by 4. So my final answer here should be 5x to the 5th, y to the 8th. That is a perfect fourth root. Okay, direct, inverse, or neither. K times x, this is direct. If that's the case, every y coordinate divided by every x coordinate would be the same. K over x is your inverse. If that's the case, if I solve this for k, I'd multiply both sides by x, and every x coordinate times every y coordinate would be the same. So I'm just going to check these real quick. If I multiply these two numbers together, I know that that is not going to give me 15. This is going to be way too big. So I know that this is not going to be an inverse variation. What I will do is check if the y coordinate divided by the x coordinate is the same. So that's 15. 15 divided by 1 is 15. 60 divided by 4, that's 15. 105 divided by 7, that's 15. You have to check all of them. So this is the situation we're in. This is direct, and the equation, the k value is the 15. So y is 15 times x. Infinite geometric series, this is on the formula sheet. All you need is your first term and your common ratio. The common ratio is any term divided by the term before it. So I'm just going to go ahead and do the second term divided by the first term, and I'm going to turn that into a fraction real quick because we are multiplying here by 1/6. That's very important. It's dividing by 6, but the way this is set up is what are we multiplying by? Okay, now first term is easy. That's the 108. We can see this. I would recommend putting this in parentheses on the bottom. If you don't, the calculator will divide 108 by 1 and then subtract 1/6 from the answer. So 1 minus 1/6. And so the sum to infinity here, 129.6. Exponential function to model equation. This is y equals ab to the x. A is your initial amount, so I've got 325 quail. Increases at a rate of 9%. The b value is 1 plus the rate if you are increasing, or this is not the situation here, 1 minus the rate. So in this case, 1.09 is going to be my b value because I'm adding 9% every time. So I have to put the 1 to account for whatever I have. So if I do 325, 1.09, like that would go ahead, and if this was just to the first, that would give me the next year. So I'm increasing and I'm adding 9% in one step by putting that 1 in front. If it's a rate of decay, then you would subtract the rate from 1.